Well, we have another question here. The question 6 says the function f defined by f of x equal to a over x plus p plus q has the following properties. First, the range of f is y element of R, y is different than 1. The range passes through the origin. The point P lies on the graph of f. Now, question 6.1. I'm going to write here 6.1. Says write down the value of q. Now we know that this is a hyperbola, okay? So we're looking for the value of q. And then we know that this is a hyperbola. It is given of the form a over x plus p plus q. Okay. Now they say that right on the value of q, q is the the horizontal asymptote of the hyperbola. So this is the horizontal asymptote. And then in the question here, it is said that the range of f is y element of R, and then y different than 1. So this, okay. The value of y different than 1 tells us that this is the asymptote, okay, the horizontal asymptote. So we say, therefore, y will be equal to actually q will be equal to 1, okay, because this is it's not defined in the function, so it's not defined in the range. Asymptote is only the acceptable y value. The non-acceptable y value is 1, so q is 1. And then the following question is question 6.2. It is say that calculate the value of a and p. Now I'm gonna say here 6.2. So we're looking for a. We're also looking for p. Now, what do we know? So far, we do know that the equation is given f of x. Now, will be a over x plus p plus q, but we know the value of q is just positive 1. Now, we need to find p and a. How can we do? What do we know from the question again? We do know that the points, they say that the graph passes through the origin, okay? So, meaning at the point 0, 0, the point 0, 0, that's the meaning of origin. So the point, it passes through the point 0, 0. Now, f of x is just y, so it's like y equal to a over x plus p plus 1. We substitute the value of y by 0 and the value of x also by 0. And now this is like 0 equal to a plus p plus 1. Now, if I move the positive 1 over, this will make a negative 1 over a over p. Then we can cross multiply this. You know, our negative 1 here has a denominator of 1. If we cross multiply, we will have like negative 1 times p, and then 1 times a. And then this will make that p equal to, or negative p equal to a, okay? Or a equal to negative p. Or a equal to, or what am I saying? Or p equal to negative a. So this is the same thing. Now we can substitute then a point, okay, to find the exact value, because a will be the opposite of p and vice versa. On a sub in the point p, because point p is given, this point here, it's square root of 2 plus 2 and then square root of 2 plus 1. Now right here, sub or maybe I should just move a little bit this other side. Uh, 6.2 still. So on a sub here, sub P in the point P is square root of 2 plus 2 and then square root of 2 plus 1. Now on a sub that point P in the equation, so remember that this is like the x and that's the y. So it's going to be square root of 2 plus 1 will be equal to, okay, because that's the y value, square root of 2 plus 1 will be equal to, at the denominator going to be square root of 2 plus 2, the x value, plus p, all over, actually under a, plus 1. Okay, so if I move this 1 over, okay, if I move the 1 over there, this will be square root of 2 plus 1 minus 1 equal to a over square root of 2 plus 2 plus p. Okay, and then this will make square root of 2 equal to square root of 2 plus 2 plus p under a. Okay, so what else can we can solve this again by cross multiplication. So we're like, because over here the denominator is 1, so we can just do all this times square root of 2, we times this, and then we do 1 times a. Okay, you know 1 times a is just a, and then square root of 2 times square root of 2 plus 2 plus p. Now we're going to do a square root of 2 times square root of 2, square root of 2 times 2, and square root of 2 times p. And then this will be a equal to square root of 2 times square root of 2 is 2, plus square root of 2 times 2 makes 2 root 2. Okay, square root of 2 times p is just p times square root of 2. Now we can write a will be equal to 2 plus, because over here we can solve this by grouping. Okay, I can write here if I factorize, not really. Okay, hold on. I prefer to group the unknown on one side. Okay, I prefer to move, then after expand, I prefer to move p roots 2 over. So this is gonna be a minus p roots 2 equal to 2 plus 2 roots 2. Now we have like a minus p roots 2 equal to plus 2 roots 2. This simply means, okay, together here, it simply means that a equal to 2, okay, and negative p roots 2, because this is the rational part, will be equal to the irrational, okay, 2 roots 2. So this will be then I'm looking for p, so I can just square root, divide both sides by square root 2, and then why? Because this will be cancel out. That I said 2 there, it's 2 there, so we cancel out, and then we'll have like negative p equal to 2. And then p will be negative 2. So therefore a equal to 2, p equal to negative 2. So those are the values of a and p. The following question then is question 6.3. What does it say? The question here, 6.3 says, sketch a near graph of this function. Your graph must include the asymptotes, if any. All right, I need to to move my board a bit here. Okay, I think I need these ones over here. Oh. Okay, P equal to -2. Et voilà. Okay, we have like 6.3 there. Now we're going to draw the graph. We already know that this is a graph of an hyperbola that passes through the origin. So I think I need to reproduce the same properties here again. Now, okay, let's say these are the properties. Okay, to draw the graph, I can use my Cartesian plane. Draw Cartesian plane. Let's say that's y-axis, and then I need to draw the x-axis. X-axis. Drawing it now. X-axis. Et voilà. Then what else? We need the axis of okay, let's say the value of 1 is over here. One because this, no, not over there, but over here. The symmetry is here. 1 is there, and then now put my line of symmetry there, a dashed line that will be like all over there. Okay, not the symmetry but the asymptotes. My apologies. So we have the asymptotes there. Okay, let's just make this is the y-axis and that the x-axis, and then asymptotes of 1 because it's there, and then the equation, the new equation of is given now by y equal to a is +2, okay, over x b is p is -2, so on right here +2, and then minus okay +1. So we have another asymptote. Excuse me. Asymptotes here 2. The vertical asymptotes. So if let's say 1 is here, 2 will be somewhere there. So the vertical asymptote will be here by 2. Okay. And then now we can, I think now we can draw the graph, but remember that the graph passes through the origin. So it passes through this point here, the origin, and then so it comes, it's gonna be like, oh no, let me do this way. Or let's just change the color. Must go like this, but will not touch, and then goes down like this, and then it will also comes like this. So this is the graph. Okay, let's just write the points here. 2 is here, and then 1 is there. Thank you.